Good day, Prof. This is the sharing of our project on Dutch auctions. Our group name is Web3 Auctioneers and consists of Richard, Charles, and myself, Lloyd. I will be presenting the project alone today. Here is the agenda for the presentation. I will start off with a quick introduction to Dutch auctions, followed by an overview of the features included in our application, a run-through of our system architecture, and finally a short demonstration of our web application. So, what is a Dutch auction? Unlike a traditional auction where the price starts low and increases over time, a Dutch auction starts selling the item at a high price before it decreases linearly with time. Bidders can bid at any point of time at a price they deem attractive. Eventually, the auction ends and the tokens are distributed to the bidders at equilibrium price. It should be noted that this final price may not be the reserve price and should be at a point that maximizes the number of bidders receiving tokens and also maximizes the profit of the token seller. For the features of our application, we have used React and JavaScript for the front end, with Ethers.js to interact with the Ethereum blockchain. Material UI is used for the styling. We are using Solidity and Hardhat for the contracts development. To improve the security of the app, we have also implemented a submarine contract, which allows for sending and revealing submarine transactions, and to distribute tokens at the end. We have deployed the app to a testing environment as well, using Alchemy and Sopolia, and use GitHub pages to serve our front-end site. I will now show a quick overview of our system design. In the center, we have the client. He will first create a token using the token factory, specifying things such as a token name, token ticker, and amount of tokens. Then he will create an auction using the Dutch auction factory. This will create a Dutch auction contract with its own starting price, discount rate, and submarine list, which is used to store a sorted list of submarine addresses by the timestamp. Next, the user has to start the auction, causing the Dutch auction to count down. Then, bidders will place their bids. It creates a submarine contract from the submarine factory, and it contains attributes like the timestamp of the bid and the current price of the token. These are used when sorting the submarine list and for finding the equilibrium price as mentioned. The submarine address is then stored in the local storage. After the place bid time is over, the bidder has to reveal his bid to the auction, and this retrieves the submarine address from the local storage and adds it to the submarine list. Finally, only one bidder is required to trigger the distribute tokens function, which will perform the distribution of tokens to bidders and execute transfers and refunds if necessary. Now, I will show a short demonstration of our web app. I've tried using localhost, but MetaMask is stalling, hence I'll be using our deployed version. For this demonstration, I'll be using the account DA_prod to create the auction, and accounts DA_test1 and DA_test2 to place the bids. Hence, I need to choose DA_prod here first and ensure that the network is Sopolia, and link my wallet. Check if the public key is the same. Yes, it is. Now I can create the auction. I'll be creating a test token TT with a quantity of 0.5, starting price of 0.5, and a discount rate of 0.0001. Since it's not found, we have to deploy it first. Deploy the token. Add this token to our DA_prod account, and then we can create the auction. This approve function is to allow the auction to distribute the tokens to the bidders at the end. So here, I will need to start the auction. place bids, we need to use other accounts. So I will switch to the bidder accounts now to place some bids. So for the DA test 1 account, I will place a bid of 0.1 ETH, which should give me around 0.2 of token TT at the end. Now I will switch to the DA test 2 account to place another bid. Now I will place a bid of 0.4 ETH. So now I need to review the transaction, the bid to the auction. So the first bidder cannot distribute the token. Only the second bidder can do that since he has reviewed his bid. So I distribute the token now. So in this case, the first bidder will not receive a refund because he did not review his bid. However, the second bidder here, he bidded 0.4 ETH. So at a price of around 0.5, he should be getting around 0.8 of the token. However, since we only create 0.5 of the token, he should only be receiving 0.5 of this token TT. And since 0.5 will cost around 0.25 ETH, he should receive around 0.15 as refund. So let's check. Yeah. Previously, this account spent 0.4. He had initial 0.5 Sepolia ATH and it became 0.1 and now he has received 0.15 as refund, so it's around 0.25. And as for the token, we can import it here. And yep, he has 0.5 of token TT. I want to add this point on the re-entry attack. As mentioned, we use submarines as a technique to improve security in our application. This also helps to mitigate the issue of re-entry attacks. As seen, we only have one function here called distribute token, which is called at the end. And this will distribute the tokens to bidders and process refunds. It is also where the bid amount is sent to the token seller. There is no recursive call within any part of this function, so re-entry will not be possible. Furthermore, here we have a map to ensure that the tokens are only sent to each account once. Hence, this ensures that no duplicate bids are processed. So this was a quick run of a general auction on our application and some features it has. If you like, feel free to visit the site here, possibleXXLogio.io/Dutch auction to try out their deployed app. Thank you for watching.